Okay, we're back for part 2 of 8.12, AP Calculus Curriculum Volume of the Washer Method revolving around other axes. In this video, we're going to do some examples with revolving around other horizontal axes than the other than the x-axis. So we're going to start with one where we let the region R be bound by the y-axis, f of x equals cosine x, and g of x equals sine x. We're going to find the volume of the solid generated by revolving R about the line y equals 5. So we're going to start like we always do with this. We're going to graph that region, and we know that y equals cosine x looks something like that. So this is f of x, and then we know that sine x looks something like that. So this is g of x, and we know that the line y equals 5 is going to be up here somewhere. We also know that the line of the curves y equals sine x and y equals cosine x intersect at pi over 4. And we know that the y value here is 1, and this is 0. So we're looking at this region bound by those two curves in the y-axis, revolved around the line y equals 5. Now, because of where I've drawn it, I'm not going to be able to go up, but we're going to generate a disk by revolving that around the y-axis, and we're going to generate this large disk first, the outside disk, and then we'll generate the smaller inside disk so that we can find the volume of the solid created. I'm going to erase this so I can draw my rectangles. Oops. I'm going to draw the large rectangle first. Notice that extends all the way to the sine curve. So the radius of that large rectangle is going to be 5 minus, and this is going to be sine x. So the radius here is 5 minus sine x. And of course, dx is the width of that. So the volume of one of those outside discs is going to be pi times the radius squared times dx. Now I'm going to erase that. I'm going to draw my inside rectangle. Well, I can get my eraser. My inside rectangle is only going to extend to the cosine curve. So the height of that is going to be 5 minus cosine x. That's going to be the radius of the disk generated when I revolve that around. And so the radius here is 5 minus cosine x. Oops. And of course the width is dx also. So the volume of the inside disk is going to equal pi times the radius squared times dx. And that gives me the volume that I'm looking for is equal to the integral. We're going to go from 0 to pi over 4. Volume of my outside disk minus the volume of my inside disk. I'm going to pull the pi out front. This is going to be 5 minus sine x squared times dx minus the integral from 0 to pi over 4. I'm going to bring the pi outside there also. And that's going to be 5 minus cosine x squared dx. These are those problems that most likely you're going to have if you're not on a calculator. You're going to have to just set up the integral and not solve it, but not evaluate it. But I'm going to go ahead and solve and evaluate in a calculator. So I'm going to do the math, 9. I'm doing the integrals first. When I do the difference between the integrals, then I'll multiply both by pi, or that answer by pi. That'll give me my answer. So I'm going to go from 0 to pi over 4. And inside, I'm going to open a new set of parentheses like we've talked about before. 5 minus sine x, close parentheses on the sine x, close parentheses on the 5 minus sine x, square that, and then the parentheses are automatically closed in this TI-84 calculator. Integrating with respect to x, now I'm going to minus the new integral, math 9, 0 to pi over 4 again. Going inside, I'm going to open a new set of parentheses to put my 5 minus cosine x. Once I do cosine x, I've got to close the parentheses on the cosine x, close the parentheses on the 5 minus cosine x, then square that, and then integrate that with respect to x again. Hit enter. Remember, I have not yet multiplied by pi. That gives me 3.64. I'm going to multiply that by pi now. So that the volume of this region is going to equal 11.442 units cubed. And if I had to do this on the exam, that's what I would do. If I had to evaluate on the calculator, that's what I would give you. So we're going to go on to the next example. This one, we're going to let the region R be bound by the curve f of x equals 2 square roots of x. G of x equals 2/3 x plus 4/3, the line. So we're going to find the volume of the solid generated by revolving R about the line y equal -1. So this time, we need to really be familiar with the graphs of these typical functions. Because 2 times the square root of x is going to look like this. And then 2/3 x plus 4/3 is going to intersect the graph something like that. Now let's think about where this is. We need to figure out where these points of intersection are before we continue. So we're going to set 2 square roots of x equal to 2/3 x plus 4/3. Now I can do this pretty easily. I can multiply both sides by 3 and divide both sides by 2. If I multiply both sides by 3, I get 2 times 3 square roots of x equals 2x plus 4. And if I divide both sides by 2 now, I get 3 square roots of x equal 1x plus 2, or just x plus 2. So that when I square both sides now, I get 9x equals, this is going to be x squared plus 4x plus 4. So when I subtract the 9x from both sides, this is going to give me x squared minus 5x plus 4. And we know this, x minus 4 times x minus 1. So this intersects at x equals 1 and x equals 4. And now we're going to revolve that around the line y equals -1. Now in this case, our f of x is our 2 square roots of x. So that's the red graph. Our line is g of x. So once again, I'm going to construct large outside disk first, revolving about this region. I'm going to create my disk, my large outside disk. So the height of that is going to be f of x minus -1, which is going to be negative f of x plus 1. So my large outside disk is going to have radius f of x plus 1, or f of x is 2 square roots of x. So it's going to be 2 square roots of x plus 1. And then, of course, dx is the width, the height of it. So the volume of one of those outside disks is going to be pi times the radius squared, 2 square roots of x plus 1 squared, times dx. Now, grab my eraser. Right. I thought I grabbed my eraser. I'm going to make the new rectangle for the inside disk that we're going to take out. Well, I should have got more. Erase more. And this time, we're generating a smaller inside disk. And the radius of that is going to be the g of x minus 1. So that's going to be 2/3 x plus 4/3 minus 1 is plus 4/3 minus 3/3, which is going to end up being plus 1/3. And dx is the width. So the volume of that inside disk is going to be pi. Whoops, getting a little carried away. Ahead of myself. And this is going to be times the radius of that inside disk is going to be 2/3 x plus 1/3. Whoa, we did minus 1. This needs to be more. We needed to add 1 because it's minus -1. So it's not 1/3. It's 4/3 plus 1, or 7/3. Be careful there. Squared times dx. And now to get the volume that we're looking for, we're going to integrate from the x value of the intersection to the x value of the intersection of the region. And so we're going to go from 1 to 4 of, this is going to be the outside disk, bring pi outside because it's constant multiple, times 2 square roots of x plus 1 all squared times dx. And I'm going to subtract out the volume of the inside disk, which is going to be pi times the integral from 1 to 4 of 2/3 x plus 7/3 squared dx. But if we just had to set up the integral and not solve it, that's what we would do. This is one we could probably integrate because it's all polynomial power rules once we expand it. But we're going to go ahead and do this with the calculator just for time's sake for the video. So we'll do math 9, integrate from 1 to 4. And this one, because I'm squaring what's inside, I'm going to open a new set of parentheses. And we'll do 2 square roots of x plus 1. Close that parentheses and square it. That's all inside my integrand. X, or with respect to x. Then subtract new integral, math 9, and 1 to 4 again for my limits of integration. And then I'm going to open a set of parentheses, and this is going to be 2/3 x plus 7/3. Close parentheses and square. That's all in my integrand. And with respect to x, I haven't multiplied by pi yet, but I'm telling the calculator to figure it. It gives me 2.6 repeating. So I'm going to multiply that by pi. And the volume of this region is going to be 8.377 or 8.378 units cubed. I like to chop so I don't make a mistake in rounding. And those are a couple of examples of revolving around other horizontal axes besides just the x-axis.